Hello and welcome back to the video lecture series on statistics for machine learning. We are going through a very important subject, and that's the probability distribution. And we have already covered one very important discrete probability distribution, which is the binomial distribution, where the probability mass function is being represented by this function ncx e to the power x q to the power n minus x. Now there is one more very important discrete probability distribution, which is known as the Poisson distribution. Okay, and for the Poisson distribution, the PMA for the probability mass function has a shape like this: e to the power minus m, m to the power x, and divided by x factorial, where m is a positive number, which is called the parameter of the distribution. Okay. If I just go for a very simple, trivial example, okay, say a particular Poisson distribution has a value of m is equal to 3. Okay, so if I want to find out the probability when the random variable has a value x is equal to 1. Okay, so what's going to be the value then? So the value is going to be e to the power minus 3 m to the power, so 3 to the power, basically 3 to the power 1, because the value of x we are assuming here is 1, and factorial 1. Okay, so this is the value. So which is what? Which is basically nothing but 3 into e to the power minus 3. Now, e to the power minus 3 roughly has a value of 0.05. If we do that mathematics, so 0.05 into 3, that becomes 0.15. So that's the value of the probability, or that's the probability when the value of the random variable is assumed to be 1. And the parameter of this distribution is known to be 3, right? Now, say for example, when can we follow this Poisson distribution? There are certain what should I say? Certain distributions which are thought to be following the Poisson distribution. Okay, let's talk about a few such examples. I mean, it might sound to be very surprising, but some of the examples include, say, number of defects in a manufacturing unit. That that has been seen to follow a Poisson distribution. Again, number of printing mistakes in a page of a book. Again, that is found to be following a Poisson distribution. Number of accidents, road accidents in a day. Okay, so all these are found to follow a Poisson distribution. I mean, it might sound to be very surprising, but that's what it is, right? So in all these kind of cases, we can use the Poisson distribution. Obviously, we have to know the value of the parameter to find out the exact value of the probability. And when we are able to find out the value of the parameter, we can find out the probability. Okay.
Just like binomial distribution, a few properties like the value of mean for a binomial distribution, okay, that is n, that's one property, and the value of variance is also is equal to n. So the standard deviation is going to be root over of n. So these are the properties of a binomial distribution. Okay, so when we come back, we are going to talk about another very important distribution, probability distribution, but this time it's not going to be a discrete distribution. This is going to be a continuous distribution. So basically, that in that case, the random variable is going to be a continuous random variable, and that's a very, very important distribution. That's called a normal distribution. So stay tuned. We're going to come back with the normal distribution. Thank you.